So we're going to talk about the law of cosines. So in any triangle ABC, we have, this is the law of cosines. So it's a little bit bigger formula here than the law of sines, which we've talked about. The law of cosines has a lot more to it. It's a squared is equal to b squared plus c squared minus 2bc cosine of a. And then there's actually two other ones, depending on what you're solving for. So what I want you to do is, again, become familiar with them, just like I've talked about being familiar with the unit circle. So here we have our a. Notice that the angle is at the end. We have b squared plus c squared, and here we have 2bc. If we're solving with the b squared, then the b angle is there, and then we have the a and c squared and the a and c. Same thing happens here. If it's c squared, it's angle c, a and the b being squared times the a and the b. So if you can get the general idea of it, and think about, there's a little bit going on with kind of like the Pythagorean theorem, a squared equals b squared plus c squared, and then realize, even though it's a little bit backwards with the letters, we're used to a squared plus b squared equals c squared. Then know that the angle c would be over there, and the a and b is times that -2. So that way you just make some connections. Connections are really good to have with all of these. We want to be sure that we're understanding what's happening. So we're going to use this to solve some of the problems that we might see in the real world. One thing I want to point out before we do that is the ambiguity in the law of sines. If you remember, the law of sines, there was some ambiguity. It doesn't happen in, that should be law of cosines, because each angle between 0 and 180 degrees has a unique cosine. So between 0 and 180 degrees, we have a unique cosine because we have positives and we have negatives. But when we look at the law of sines, between 0 and 180, there are two angles that have the same value for sine. So there's two that have square root of 2 over 2. There's two that have square root of 3 over 2, and two that have 1/2 on just our unit circle. There are other ones that have it elsewhere. So just looking at those, we can see in that 0 to 180, we get two possibilities for the law of sines. But cosine, they are going to be a positive and a negative for each one. So it makes it unique, so you won't have to look for the ambiguous cases in the law of cosines. All right, so let's go use our law of cosines to solve a problem. So we are looking for the length of a tunnel. So a tunnel is to be built through a mountain. To estimate the length of the tunnel, a surveyor makes the measurements of 388 feet, 212 feet, and 82.4 degrees, as shown in our picture here. We're going to use his data to approximate the length of the tunnel. So we're looking for the length between A and B. And that is also known as our little c. If this is our big C, this is our little c. This would be little b, this is little a. We need to understand that part so we know what we're solving for. So for this problem, we're solving for little c. So I am going to write this as c squared is equal to a squared plus our b squared minus 2 times ab times the cosine of angle c. So c squared is equal to our a, across from a, is going to be 212. So 212 squared. Our b was 388 squared. So minus 2 times our a times our b times the cosine of the angle that we were given, angle C, which is 82.4 degrees. Now, you can piece this out, or you can put all of this into a calculator, and that's what we're going to do. So, So we're going to have 212 squared plus 388 squared minus 2 times 212 times 388 times the cosine of 82.4. And that is what c squared equals. So it's 173730.2367. Now, we want to take the square root of both sides. So c, so I'm going to use some of my second square root, second answer again. So I'm again pushing that answer key. So I'll have to type that in. And I get 416.809. We're going to go with 417 feet because the other distances were not decimaled. So 417 feet. Now, this is not going to be a plus or minus because distance cannot be minus. And that's our answer. All right. So let's go to another example. So if we are given that A is equal to 5, and B is equal to 8, and C is equal to 12, we want to find the angles. So we're going to, in just the sides, we need to find every angle. So let's start with angle A, just for the choice of it. So angle A, we're going to use the A squared is equal to B squared plus C squared minus 2 BC cosine of A. Now, you can do one of two things. You can plug everything in, or we can move everything about a little bit to get it to where it's solving for A, and then we can plug in the numbers. And you can use, if you understand that shortcut, you can use that to solve in the future. So I'm going to go ahead and do that so you can see what I'm talking about. So I'm going to subtract B squared and C squared at the same time from both sides. So I get A squared minus B squared minus C squared is equal to a negative 2BC times the cosine of A. Now we'll divide both sides by negative 2BC, and you end up with the cosine of A is equal to your A squared minus B squared minus C squared all over negative 2BC. So now we can solve for the cosine of A and then take the inverse. You can put all of the values in first, or you can take it down to this. And if you make connections again, the cosine of A would be starting with our A squared minus B squared minus C squared over negative 2, and the B and the C still match. So I can easily transform this to the cosine of B. So if I wanted to transform this to cosine of B, would be equal, I know that the B squared would be first, minus our A squared minus our C squared, all over negative 2 AC. So if you can make those connections that the B and the C or the A and C still match, and then the angle you're solving for, that letter will be up front. And you could do the same thing with the C's. So that can make it a little bit easier rather than trying to plug all the numbers in and then moving everything over. So we have kind of a formula we can use. All right, so let's go use this formula to find our A. So the cosine of A would be equal to, our A is 5, so 5 squared, minus 8 squared minus 12 squared all over negative 2 times 8 times 12. All right, so let's go put this in our calculator. Now, if we're putting in the calculator and you're not using a fraction thing, you're going to have to parenthesize the top. So we'll have 5 squared minus 8 squared minus 12 squared, close out the top, and then divide by, the bottom is all multiplied, so it should follow the order of operations, but if you want to be sure, you can put all of that in. So negative 2 times 8 times 12 in parentheses, because that way we're dividing by everything. It will follow it, but it would probably divide by the negative 2 and then multiply. So you want to put the bottom and the top in parentheses if you're not going to put it in a fraction format. All right, so we end up with 0.953125. So now we've got to take the cosine inverse of that 0.953125 to find our angle A. And again, I'm going to use my second cosine inverse and then do that second answer again, because that puts it all the way in, and I get 17.6 for my angle, so I'm just going to make it 18 degrees. So depending on what your instructor is looking for, I find it a little bit easier to use whole numbers, and we're not doing anything like an engineering place, that kind of thing. So I tend to go with, it's okay to use the whole numbers to make the math easier. When you start putting in all the decimals and then you're squaring, it can get a little bit complicated. All right, so we found angle A. Let's go use what we have for what I've already solved for cosine B. We are going to solve for angle B. So we'll have the cosine of B is going to be equal to, this time it's B squared first, so 8 squared minus our A squared minus our C squared divided by negative 2 times our A times our C. All right, so let's go. Remember, we're going to have to do some parenthesizing here. So we get the whole thing divided by the whole thing. All right, so we'll have 8 squared, so parentheses, 8 squared minus 5 squared minus 12 squared, parenthesis, divided by parenthesis, negative 2 times 5 times 12. Hit enter, and we get 0.875. So angle B will be equal to the cosine inverse of 0.875. So we'll do second cosine inverse, second answer. So again, we're putting the answer in, and I don't have to type it. And we get 28.95, so we'll go to 29 degrees. All right. So now for angle C, you could go do all of that, or remember, all of our triangles equal 180. So we can say that C is equal to 180 minus our angle A of 18 and our angle B of 29, and that'll get us 133 degrees. So we have found all three angles. All right, so let's go look at another type of problem that we might experience out in the world. So this is heading and bearing. Let's talk about it a little bit, and then we'll solve a problem like it. So in navigation, a direction is often given as a bearing. That is an acute angle measured from due north or due south. The bearing, north 30 degrees east, indicates that a direction that is 30 degrees east of due north. So north of 60 degrees west would be that it is 60 degrees west of due north. South of 70 degrees west would be 70 degrees west of due south. And south 50 degrees east would be 50 degrees east of due south. So that kind of gives you an idea of what we're talking about. So let's go look at our navigation problem. So we have a pilot who is set out from an airport, and he heads in the direction of north 20 degrees east, flying at 200 miles an hour. After 1 hour, he makes a course correction and heads in the direction of north 40 degrees east. Half an hour after that, engine trouble forces him to make an emergency landing. We need to find the distance between the airport and his final landing point. Find the bearing from the airport to his final landing point. All right, so we've got a graph here that we can look at. Let me zoom in on this for a second so we can talk about it. So he started out with flying north 20 degrees east of it. So north 20 degrees east. So that's 20 degrees east of due north. He was flying 200 miles an hour. After 1 hour, he makes a course correction and heads in the direction of north 40 degrees east. So that means he was now at 40. So if he started out at 20 degrees east of due north and now he's 40 degrees east of due north, he made a course correction of 20 degrees. Now, he flew for half an hour. So for a half hour, because he was doing 200 miles an hour, if he only did a half hour, he now is at 100 miles is how far he flew at that point. Now the engine trouble forced him to make an emergency landing. So we've got some information here. One thing before I pull away from the diagram I want you to understand is if he was going 20 and now he's going 40, that means his course correction is 20. And if we have a line, pull up a piece of paper here. If we have a line like this and we know that that course correction is about 20 degrees of this, we know that from here to here, a straight line is 180 degrees. So we can find this angle. It's not 40 because 40 is the total angle. He did half of that because he was already flying at 20 degrees. So now he's doing 40. That means he did another 20. So if we take 180 minus the 20 on this side of it, we can find our angle B. So sometimes we just have to have a little bit of knowledge of our triangles and a little bit of maybe geometry to kind of help. Not a whole lot, just a little bit always helps. All right, so the first thing that we can find for our triangle is our angle B. So we know that angle B will be 180 minus that 20 degrees course correction, which gets us 160 degrees. And we know that this is angle B, so we're trying to find the side across from it, the length from the airport and his final landing point. So we're looking for little b, so we're going to do the b squared is equal to a squared plus c squared minus 2ac times the cosine of b. All right, let's plug in what we know. We have b squared. Our a squared, if angle A is here, little a is across from it, so that's 100 squared. C squared, well, across from that was 200 minus 2 times 100 times 200 times the cosine of B. So we're going to do this one the long way instead of using our shortcut we used on the previous problem. All right, so we've got 100 plus, cosine of B. We actually know B, this should be 160 degrees, and we can put all of this in. So we can go put it in our calculator. We will have 100 squared plus 200 squared minus 2 times 100 times 200 times the cosine of 160. And we get a very, very large number. So our b squared is equal to 87587.70483. Now we're going to take the square root of both sides. So second square root, second answer, again, so I don't have to type it in, and I get 295.95. So I'm going to round that to be 296 miles. So B is 296 miles. This is from his starting point, from the airport. From the airport, that's how far this is. Now we need to find the bearing from the airport to his final landing point. All right, so to find that, we are looking at finding the angle that is right here. We need to find this angle of A because we need to add it to the 20 degrees because we're going to do due east, or east of due north. So we need to find angle A. So we're actually going to use the law of sines to find this, because we know that A over little, the sine of A over little a would be equal to, and we can use the ones that we know. We know that angle B, and we have our little b. We don't know angle C, and we don't know angle A, so we can't use C, but we can use angle B with its distance that we just found, and we have the length of A. So, all right, so we will do angle A. Let me switch colors so you know we started a new part. Angle A, we'll use the sine of A over 100 is equal to the sine of angle B over that distance we just found. So, we'll just do 296. Alrighty, so we'll cross multiply. So we have 296 times the sine of A is equal to 100 times the sine of 160, and that's a degree. Divide by 296. And again, you could just multiply that side by 100, but I like to always give my students, this is the same thing you're going to do each time, because they seem to do better with that than trying to figure out what to do next. Alrighty. We're in degree mode, so we'll have 100 times the sine of 160 divided by 296. All right, so here is our value. So the sine of A is equal to 0.115547 ... I'm not going to write all of that out. So then we'll take the sine inverse to find our angle A of that 0.115547 ... So second sine inverse, second answer, and we get 6.636. So let's go with 6.6. So it'll be equal to 6.6 degrees because we can go to one decimal place. All right, so if we have 6.6 degrees, then you could always go up to 7 if you felt like you wanted to. So 20 degrees, we're looking for that entire angle. We have to add the angle that was already there because we want to go due north. 20 plus 6.6 would equal 26.6 degrees east of due north. So if we're looking for the bearing, it would be that we're going north 26.6 degrees east. This would be your final answer, putting it in that bearing mode. And again, if you wanted to round that to 7, you can do that. I would be okay with that in my class. Always look to see what your instructor is doing because they're the one that's grading your items and what they think is okay and not okay. All right, so we have another problem that we're going to do. The next problem we're going to do deals with the area of a triangle. So we are looking at a formula here. It's going to be called Heron's formula. It allows us to find the area of a triangle from the lengths of its three sides. So we don't have an angle. We're just going to find it by the triangles. So it's given by A is equal to, you're going to have S, and S is going to be 1/2 of those three sides added together. So basically, half of the perimeter, so the semi-perimeter. You're going to take your S, and then you're going to multiply it by that semi-perimeter minus each of the sides, and then take the square root of it. So we are going to use that to find, with this problem, the area of a lot. So a businessman wishes, and let me zoom in just a little bit so you can see a little better. Businessman wishes to buy a triangular lot in a busy downtown location. The lot frontages on the three adjacent streets are 125, 280, and 315. We want to find the area of the lot. So here's our lot. We want to find the area of that. And we're going to use this formula here. But first we have to use this one to find the S. Alrighty. Let's get a new piece of paper. So again, our three sides, which is what we need to know. The sides are 125, 280, and 315. That's what we need to know. So the first thing we have to do is find our S. And our S is the three sides added together. And we're going to divide by 2. So the total of adding those would get us 720 divided by 2 is 360. To find the area, we'll plug that into our formula. So we have S, so remember it was S times all of those sides subtracted from S. So it'll be 360 times 360 minus side A times 360 minus side B times 360 minus side C. And then we can put that into a calculator. So let's turn it on, and we'll have second square root of 360 times 360 minus 125 times, and I'm just putting it in parentheses so I don't have to use the times key, times 360 minus 280 and 360 minus 315. And we end up with 17,451, and we'll go to 1 decimal place. All right, so our A is equal to 17,451.6. So we found the area. Well, let's go a little bit further. Let's say that it is $25 a square foot. That's our area, and our area would be with that. So all we have to do is take that and multiply it. Let's find the value. So 17,451.6, and we would multiply by 25, and we'll get 436,290. So we could find the value, which you might see in your homework. Once you find that area, now you can multiply it by the cost and find out how much it would be worth, or how much, because they said he wants to buy it. If it's that, he could figure out what its value is if the current market is at $25 a square foot.